This video is going to discuss lenses and mirrors. The objective is that students will be able to recite the equations and properties of how light reacts when contacting lenses and mirrors. First, let's talk about flat mirrors, otherwise known as plane mirrors, like a geometric flat plane. Light striking a flat reflective surface, like a regular mirror, will bounce off at the same angle it entered. This is called the law of reflection. So if it comes in at 20 degrees, it'll reflect at 20 degrees. The incoming light is called the incident ray, as you can see in the picture. Get the laser pointer here. Boom. So this is the incident ray. That's the incoming light ray going into the mirror. The reflected light is called the reflected ray. Not really creative there. The normal line is this dotted line in the picture, and that's an imaginary line drawn perpendicular or at 90 degrees to the surface of the mirror. This is the line that the incident and reflected angles are measured to. So you don't want to measure an angle down here with the mirror. You actually measure it with respect to the normal. So here's the angle of incidence, or the incoming angle, and here's the reflected angle, or the angle of reflection. So let's look at this diagram. Which one of those angles, A, B, C, or D, is the angle of incidence? And which one's the angle of reflection? So the incoming light starting up here, so the angle of incidence is either A or B. Is the angle of incidence measured with respect to the mirror or with respect to the normal line? With respect to the normal line, so it's B. It's going to be this angle over here. How about the angle of reflection? Is that going to be C or D? That should be C, again, with respect to the normal line. So you're not worried about these types of angles, A and D, that are like next to the surface. So a ray of light is incident towards a plane mirror at an angle of 30 degrees with the mirror surface. What will be the angle of reflection? If you said 30 degrees, that would be incorrect. The reason why is the normal line is perpendicular, and that's right here. So if you think of this angle right there as 90 degrees, then the angles of incidence and reflection are going to be 90 degrees minus 30, which will be 60 degrees. So it'll be this angle up here or this angle over here. Again, measured against the normal line, not the surface of the mirror. What about curved mirrors or lenses, which are also curved? These are not going to just have light bounce off in the same exact angle. These are going to do different things to light. So we'll do this lab in the near future with a candle and a mirror, and you notice the flame's upside down, and that's kind of crazy, but you'll see that for yourself and we'll explain why. That'll be neat. Curved mirrors, like if you take a spoon and look at two different sides, like the outside, this is the convex side of the spoon, the side that's bowed out. Everything would look kind of bubbled, but everything would still look otherwise the same. Everything's right side up. If you look on the inside of the spoon, depending on how far away you are from it, you'd see everything upside down. You could try this with most spoons as long as they're kind of shiny and reflective, and you can see for yourself. To be able to explain how in the world that happens, all these weird, curvy, warped looking pictures, sometimes upside down, we need to first define some new terms. If we have an object in front of a lens or mirror, the distance between it and the lens is called the object distance, which we'll call DO. So DO is the object distance, and that's the distance between the lens and the mirror. DI then is the image distance. That's how far away from the lens or mirror that the image forms. HO and HI are the heights of the object and image. So that's just how tall it is and how tall the image is. The focal length of a mirror is a measure of how much it bends light. So the more a lens bends light, usually that changes its focal length. And that's something that's either going to be in the equation that we're going to solve for, or is given to us in the problem. So let's go over these equations now. There's a series of equations that help relate all these new terms for lenses and mirrors. F stands for the focal length. DI and DO are image distance and object distance, as described on the previous slide. And there's something else called magnification, which is pretty self-explanatory, but if you've ever seen a mirror that makes your image look bigger than normal, then that's magnification. And we can solve for magnification in two ways, either doing the image distance divided by the object distance, or by doing the image height divided by object height. This equation can also be used without magnification at all, and you can just relate these four things: the image distance, object distance, image height, and object height. We'll go over how to solve these in more detail in class. That's it for this video. Thanks for watching. Remember to do the Edmodo questions and bring your notes with you to class to help on the note quiz.